family mode.
Good evening, everybody, and welcome to another highly charged and highly interesting edition of vBrownbag US. We are continuing with our AWS Solutions Architect Associate Certification training month, learning all about the cert, learning all about what you need to know to pass the test, etc., etc. Tonight we have one of the all-fivers, somebody that has all 3 associate exams and the 2 professional exams underneath his belt. His name's Tim Patterson, with the well-deserved hashtag of AWS champ. A couple of housekeeping notes. Getting on the conversation at vBrownbag. I'll be watching the Twitters. If you guys hashtag vBrownbag or respond in the Q&A panel from the webinar, I will be able to field the questions for Tim. Obviously, we're at Professional VMware / Brownbags. And I was also asked by Damien to remind everybody that if you're going to VMworld, that VM Underground tickets we still have a couple left, so go to vmunderground.com and get your VM Underground ticket, and also the first day tickets are free, so grab those from the exact same website, vmunderground.com. Like I said before, our guest tonight is the illustrious Timothy Patterson, AWS champ. His website is Tim's Virtual World. I'm checking it out right now, and it's really good. My name's Mistwire, mistwire.com, and Tim, you there?
I'm here.
Awesome.
Thank you.
I'm going to turn it over to you. Make presenter. Shablam.
All right. Hopefully everybody's with me.
I can see your screen.
All right, perfect. So tonight we're here to talk about Domain 1, Part 3 of the Certified Solutions Architect Associate Exam Study path. We're continuing along the track of designing highly available, cost-efficient, and fault-tolerant scalable systems. As Chris mentioned, I'm Tim Patterson, and let's get the show on the road. So who is this guy? I actually work for Amazon now as a senior technical account manager, but I do have a disclaimer. Everything I speak about tonight is my own point of view. It's not owned by Amazon, it's not promoted by Amazon, and it's just based on my own past experience and the public documentation. I do possess all 5 current Amazon certifications that are available, and I'm looking forward to whatever they decide to release in the future. So why are we here? We're here to continue learning about the certification, but along the way I hope that you pick up some other tips and tricks as well that may help you in a day-to-day role if you are in a company lucky enough to be adopting AWS. What I hope to cover specifically tonight are developing solutions to match client specs, including availability requirements, budgetary constraints. Along the way, I will definitely dive deep on the difference between on-demand, reserved instances, and spot, as well as talking about some different RTO and RPO DR design options. Very important in today's cloud-based world. I have a couple of scenarios and live screens to show you along the way. I typically do not like to teach just off of a slide deck, but for some of this material it's really hard to do a live demo with. So bear with me, and I'll try not to bore you too much along the way. So I wanted to start out with a quick primer, and I'm sure this is something that everybody has seen before, but I want to level set with our terminology before we get too deep in the weeds here. One thing that I hear a lot get confused just throughout my career, I've heard people interchangeably use regions and availability zones. And I want to make sure that this concept is very clear. So a region is a geographical region. Amazon is, I don't even remember the exact number, but there's a lot of regions across the world on just about every continent. And within each region, there are these constructs called availability zones. And an availability zone is a separate, discrete, you can think of it as a data center. It's completely separate from the other availability zones in terms of power, location, network backbone, that sort of thing. So you can definitely think of them as separate data centers. It's a good analogy. But they are clustered together within that specific geographical area of a region. continuing on with the review, I want to talk about some of the services and specifically their locality. And what I mean by that is, where does the service run? Where is it available to? And this becomes very important as we start to discuss some of the well-architected options and some of the disaster recovery options later on in this show. So Amazon has a multitude of different services. Some of their services are considered to be global services. And what I mean by that, and we'll just use CloudFront as an example here, CloudFront is the content delivery network service that Amazon offers. That service is consisted of, I believe they're at up to 100 plus POPs around the world now. And it's you manage it through a single interface, and any change you deploy is deployed globally. IAM, Identity and Access Management, those configurations are applied globally, but management endpoints only exist in US East 1. Pay attention, I'm calling that out. Route 53, distributed DNS service, that is deployed also around the world. You can change the configuration, it gets deployed, highly available, scalable, very resilient DNS service. S3 is considered to be an Amazon global service, but S3 actually has a concept of regional endpoints. S3 does use a global namespace though, so like an S3 bucket name has to be globally unique across the world. So therefore it falls under global. But I want you to pay attention, it does have regional endpoints. Region-wide services, just about everything else. There are no AZ-specific services. There are a couple of AZ-specific caveats. For example, an EBS volume that you create is tied to the AZ that you created in within the specific region. Same applies for like a VPC subnet. Subnets cannot span multiple availability zones. An ELB, an elastic load balancer, can be configured to be single AZ or multi-AZ. Again, that is very important as you're making design decisions for any kind of application deployment architecture. In an auto-scaling group, hopefully everybody's familiar with an auto-scaling group. It lets you spawn instances up and down in response to real-time demand configurable metrics. Those can also be single AZ or multi-AZ. And this is not an exhaustive list of all the Amazon services out there. But it is important to understand that some services have different locality, and especially some of these caveats with EBS volumes and subnets, those all come into play a little bit later. Got too far ahead of myself. All right, EC2 instance purchasing options and use cases. So I'm pretty sure everybody knows what an EC2 instance is. It's a virtual machine running on the EC2 Elastic Compute Cloud Service. But there's different ways to pay for instances. And part of the exam objectives is knowing when to choose which type of purchase option. So there's basically three different types. An on-demand instance, it lets you pay for your compute capacity by the hour. There's no long-term commitments or upfront payments. You're billed immediately for an hour as soon as you launch the instance. That's a little known fact that some people do get confused on. It is per hour billing, and once you launch it, you're responsible for the entire first hour. Pro tip, this is a little segue, but watch out for flapping auto-scaling groups. So I've seen it in the past where bills get ran up way high from someone that has an auto-scaling group that immediately boots up, fails its health check, gets terminated, a new instance comes up, fails its health check, gets terminated, and it continues on in a loop. Every time an instance gets launched, you're paying for that entire hour. So that's just something to watch out for there. The second purchasing option, a reserved instance. Reserved instances provide you with a huge discount. I mean, it can be up to 75%. All this pricing information is publicly available on Amazon's EC2 pricing website. But huge savings over on-demand instances. And what happens is there's different purchasing options for a reserved instance. You can pay for a 1-year or 3-year term. You can pay all up front for that instance and get the biggest discount. You can pay partial up front, which means you're putting like a down payment on a car essentially, and then you get a discount throughout the term, or no upfront, where you do not put any money down, but you do receive a discount across the term. The kicker is you are responsible for paying for that entire term. There are options to resell a reserved instance on a public marketplace, but that's too deep of a segue here. But with the reserved instance, you are assured that your instance will always be available for the operating system and availability zone in which you purchased it. So thinking DR scenario here, if you purchase a reserved instance, you're guaranteed that instance will have the capacity to run. Now, a note with reserved instances, another kind of gotcha that people stumble on. When you purchase an RI for short, you don't actually tie it to a specific instance. It's actually taken off of your bill at the end of the month. And the flexibility there is you're not stuck managing, okay, this is my RI, this is not my RI, things like that. It just comes off the top of your bill. You are reserved that capacity, and any instance of that same instance type can actually utilize that capacity. So it's more of a billing purchase option as well as a capacity reservation. And then finally, the third purchasing option are spot instances. And spot instances are some of my favorite. They provide the ability for customers to purchase compute capacity with no upfront commitment and at hourly rates usually lower than the on-demand rate. Spot instances are awesome. It's how Amazon sells their excess EC2 capacity. So if you imagine Amazon's got these, I don't even have any idea how many servers they have out there, but all this extra compute capacity just sitting on a rack, not being used, that's what you're bidding on for a spot instance. Just a little breakdown here, some of the use cases. So for like an on-demand, my favorite use case there are like applications that are being developed or tested for the first time. Your dev test, a lot of times you want to ensure that that instance is running. Spot's also great for dev tests, but a lot of times, well, think of it this way, how frustrating would it be if you were in an SSH session coding away and all of a sudden your instance is terminated due to your bid not being high enough? I mean, that would be a little frustrating. But other use cases, low cost, no upfront payment, long-term commitment, gives you flexibility to scale. Elasticity is always a must for cloud-based applications. Applications with short-term, spiky, or unpredictable workloads that cannot be interrupted. So here we're talking application SLAs, things like that. We'll talk about that a little bit later. Reserved instances, steady state or predictable usage. So if you have an application that you've deployed to the cloud, excuse me, and you know that it's going to be running 24/7, 365, a reserved instance is a great way to save cost and guarantee that that application will continue to run. Users are able to make the upfront payments to reduce the cost, and there's a lot of third-party vendors out there that'll help you determine that break-even point between running with on-demand instances or reserved instances. The Amazon marketplace is full of vendors willing to help. There's a lot of good products out there. Spot instances. So if your application has a flexible start and end time, or it's a very bursty workload, if you have a need for a huge amount of processing capacity, but you only need it for a couple of hours. Let's say you're processing from a queue. Spot instances are typically a very good way to go. And speaking of Spot actually gets a little more complicated. So within the Spot family, there's actually what I consider 3 different types of Spot instances. So you have a normal Spot instance, just plain old Spot. It enables you to bid on unused EC2 instances. It lowers your costs. We already covered that. But your Spot instance runs whenever your bid exceeds the market price. Okay, and what I mean by that is you actually do have to put in a bid. It's almost like an auction. Amazon is auctioning off this excess space. And you can actually get pretty good breakdowns. So here, I believe you can still see my screen. I've got a web browser pulled up here. Yep. And we'll just take a look at the pricing history for 1 month. So what this is doing is it's going to load up a graph of the price for an M3 medium instance type, and this is all configurable, running Amazon Linux, and it's going to show me the average market price of these instances when it finally decides to load. And this is when we welcome ourselves to the wonderful world of live demos.
If it's not a broken live demo, it's not a real one.
That's right. All right, here we go. So you can see that there's actually some spikes where a market price for an M3 medium instance actually goes up to about 70 cents. What that is telling us is that Amazon is actually constrained for capacity somewhat within these time periods here. And this is going back a month, so this is a long ways. Or there was some kind of API issue, things like that. But typically, let's just go back a week here. You'll be able to see the amazing price difference. AWS instance pricing. Okay, so you can see, like, for August 14th, the high spot was just over a penny an hour for this instance type. When you look at an M3 large on demand, you can see that you're charged 13 1/3 cents per hour for the same exact instance. So that's kind of the power of Spot. If you're okay with putting out a bid, so in this case we could bid 3 cents, and that instance would continue to run. You could have ran this instance from the 12th all the way to present time, and it would not be terminated because your bid price is above market price, and you're still getting significant savings over on-demand pricing. Hopefully this is still making sense here.
Mm-hmm.
Okay, and getting back on track a little bit. So if the market price does exceed your bid price, your instance is terminated. Amazon does give you a 2-minute warning period. And what you can do is there's this thing called the EC2 metadata service. And what it is it's like a web service that's running on your link loopback, your 169 CIDR block family. And what you can do is it's a RESTful interface. Like if you're on Linux, you could have a curl every 5 seconds checking this. And there's actually a URL you can call that tells you how much time does your instance have left. Has it been marked as terminated? If yes, okay, it will count down from 2 minutes. And what you can do is you can intelligently use your own scripting, whatever method you're comfortable with, to actually shut down your application, ensure all of your data has been saved back to persistent storage, whether that's S3 or a database or some other means. And that way no data is lost, your Spot instance terminates, life is good. You wait until your bid price comes back above market value. So that's Spot in a nutshell. Spot blocks takes it to another level. So AWS does not terminate a Spot instance with a specified duration, also known as Spot block, when Spot price changes. So let's say you have this processing workload that you do every day from 3 p.m. to 5 p.m. You know it happens during that time. You want to spin up a whole bunch of Spot instances to hurry up and process through whatever workload queue you've got going on, or whatever kind of pipeline you've built. Spot block is ideal for that. It takes a finite time to complete, batch processing. You specify your duration, and the price you pay depends on the duration. So the Spot block pricing is a little different than the regular Spot market. All that's right available through the Amazon console. But the power there is once you've paid for a duration, your instance cannot be terminated under normal circumstances during that that time duration. I say under normal circumstances, if there's a hardware failure in the back end or something like that, I mean, things happen, but Amazon will not willingly or knowingly terminate your instance during that time block.
Quick question.
Sure.
During a normal spot instance, after you've gotten the 2-minute warning and your time is exceeded and the server has terminated, does the server automatically restart once the pricing drops below your bid price again?
That's a very good question. So what will happen in that case is as long as your bid is still active. So there's a separate object out there called the spot bid. If your bid is still active, it will be fulfilled again. As long as you haven't pulled your bid out of the running. You can also launch spot instances with auto-scaling groups. So you can configure an auto-scaling group to have a bid price, and you can actually change your bid price. You can update your auto-scaling group to a higher bid price, and it will definitely launch a new instance to fulfill that gap. But yes, if your bid remains the same, market price drops below, you will get your instance back. Absolutely.
Cool.
Okay, so the third type of spot instance is a spot fleet. And basically a spot fleet is just a whole set of spot instances that are based on criteria that you specify. So a spot fleet, you can say you need at least X amount of RAM, Y number of CPUs, different parameters that you enter into the console there, or API, command line, whatever your poison is. But Amazon will take that desired configuration and it will fill it with whatever kind of instance it can find that meets those minimum specs and push those out as a one-time request. It does not persist once all of your instances have been terminated, but they're set to maintain the target capacity by relaunching replacement instances after instances in the fleet are terminated, but the fleet itself is a one-time request. So basically, Amazon will do the heavy lifting for you. It'll find what instances meet those specs, deploy it in one big batch, and away you go. It's another very powerful option there. So some strategies for using spot instances, and these might have become somewhat more clear as we've stepped through these slides here, but just to point out, the key difference between spot and on-demand are that spot instances might not start immediately. So I mentioned the concept of this spot bid. Your bid is how much you're willing to pay, and if there is not excess capacity to meet your bid, your instance is not going to start right away. That's where on-demand has some advantage. On-demand, you will get an instance right away. You do pay the higher price, but there are some cases where it's worth it. But with the spot bid, when it is eventually filled, it can be terminated again if the market price changes. So one strategy to combine these two is to actually launch, let's say you have a web app and you get a lot of spiky traffic depending on like if an article is posted or something like that to your site. You have the most popular blog on the planet. So one strategy to remedy that is you can actually launch a core group of on-demand instances to give you your baseline capacity. Then you can augment those with spot instances when the opportunity arises to help save costs there. A separate strategy is you can use spot block if you know that your traffic is only spiky between the hours of noon and 6 p.m. A 6-hour spot block is perfectly acceptable. But just to jump back to the live console here, I mentioned that auto-scaling groups can be configured with spot instances. And what I have here is I actually have two auto-scaling groups set up. I have an on-demand auto-scaling group for my web app, and I have a spot instance auto-scaling group for my web app. And the only difference is, let's see here, the auto-scaling group is configured to launch two spot instances. They're both in service. If I go up to my spot requests, you can see The actual bids are listed here. They've both been fulfilled. I'm bidding 10 cents for an hour, just to ensure that I have the instances for this demo. But it's an M3 medium. And what I've done is I've created two separate autoscaling groups, the on-demand and the spot. Where this gets powerful is I created a single elastic load balancer that we can see here in just a second. Hopefully. But I created a single elastic load balancer, and what that does is it front ends both of those autoscaling groups. So as traffic increases, our autoscaling groups are configured to detect that spike in traffic, and it will scale up spot instances if they're available. Now where this gets powerful is you can actually write some of your own logic to say, okay, if spot's available, great, scale up with spot. That's very cost effective. If spot is not available, then you increment how many instances you want in your on-demand autoscaling group. You're guaranteed to get those instances, albeit at a likely higher price. So here you can see there's 3 instances in service. 2 of these are coming from spot, 1 is coming from on-demand. That's the power of being able to mix the two together. You can build some very cost-effective solutions along the way. And on this slide, I've actually provided a link to a blog post I found online. It's a third party, but I believe it does the best job of trying to communicate this concept, as well as it provides some sample code on how to actually automate increasing those autoscaling groups independently. I highly recommend you take some time and read it, because this is a proven strategy out in the field for not only providing resiliency for an application, but also ensuring that you're optimizing your spend. So now we get to talk a little bit about client specifications. And client specifications are more commonly known as customer requirements. Clean, clear, and concise communication is always key. It doesn't matter what you're actually trying to build, if it's something in Amazon, something on premises, it really doesn't matter. Whenever you're talking with a potential customer, whether it's another business group or an actual paying customer, you have to make sure that they say what they mean to get what they need. If the requirements are not communicated clearly, the end state of the application is doomed from the start. Make sure that you fully understand what is expected for a given situation. So this also applies if you're taking an exam. The exam questions, just from my past experience, are sometimes worded to trip you up a little bit. Make sure that you're paying attention. Look for keywords that should drive you to your ultimate solution. What do I mean by that? If there's a scenario where something says the application must be highly available, or it's mission critical, it has an SLA, it must be redundant, it must have replication, it should immediately trigger in your mind, okay, there should be no single points of failure. Side note here, single point of failure can be the Amazon API layer itself. Never assume that the API will always be available. Make your applications that have health checks built in through Route 53 or through CloudWatch alarms, things like that, that are completely separate from the management API layer. You can get throttled if you're using too many API calls. Things happen. If you hear that your application must be highly available, use multiple AZs and regions right off the bat. You cannot have that single point of failure, and a single AZ application deployment is a single point of failure. The AZs are built as robustly as they can be, but stuff does happen. A lot of times it can be out of Amazon's control. Sometimes ISPs have problems communicating in. There's just so many layers here. Make sure that you deploy into multiple AZs at the very least. Going back to the API thing, you must survive an outage without human intervention. Make sure that your instances can bootstrap themselves. Make sure that you have that active health check going, either from within your own apps or from Amazon services, third parties. Make sure that something out there is watching your infrastructure and can take action on it. Another completely separate topic, but Lambda is great at that. It's a great Swiss Army knife tool. Scalability. So if your application must be highly available, you have to be able to scale out and or up to meet current demand. If your application is getting absolutely hammered, you don't want to be susceptible to a denial of service. Make sure that you can scale out as quickly as possible. Kind of playing the devil's advocate a little bit, if you hear a customer say that my app is mission critical, it must be highly available, and you consider all the above points, you also have to think, is this feasible given the budget that the customer is willing to spend? Sometimes, keeping costs in mind, you do have to push back a little bit. Sometimes you push back on the customer saying, hey, look, here's what we can do for you, but your budget is way too low. You have to come back to the well with a bigger bucket. Or you can make some compromises and trade-offs along the way. It all depends on what you're deploying, what the actual project is. Just make sure that all options are on the table, everything is heard, and that all parties are in agreement at the very end. The flip side, if somebody tells you, my application must be cost-effective, or it has to be cheap, I have budgetary constraints, I want it to be burstable, or it's a demand-based workload, what does that trigger in your mind? Are spot instances a good use case for this? Is it okay to deploy this application in a non-highly available fashion? Is this a time-based workload? So going back to that batch processing, is it something that only has to run a portion of the day? Is it queue-based? Is there something external to the application that's keeping track of state where if my instance is doing the processing were to just disappear, the business is not dead in the water? So you really have to pay attention when looking at customer requirements, the difference between these two items. Some requirements require you to be highly available and cost-effective. In that case, things like RI start to pop into my head. Okay, you need cost effectiveness. You always have to have your instances on. RIs are a great option. A little scenario, and this is somewhat of a trick question that combines some things I talked about earlier into this topic. So client requirements. Client comes to you. My application must be available 24/7, 365, basically all the time. It has to survive a single AZ outage. And my EBS storage that I'm using must be consistent. We're not using eventual consistency here.
Oh.
What would you do? So some of the caveats here, let's just break this down a little bit. Application must be highly available. It has to be online all the time. Immediately that triggers, okay, I'm going multi-AZ. No questions asked. Must survive a single AZ outage. Perfect, we got that covered. EBS storage must be consistent. Well, we learned way back during this review that EBS volumes are tied to an availability zone. So even if my application is deployed using the best cloud auto-scaling technologies out there, how am I going to get my data from one AZ to another? And this is a real-world scenario that I have run into in the past. Sometimes you have to think outside the box. So in this particular case, Amazon does not have a solution for this today. What you have to do is take matters into your own hands and replicate the data. I'm not sure any of you Linux users out there, if you've heard of DRBD, that would be a great solution for this. An actively replicated block device. You can use the network links between the AZs. That's perfectly acceptable, and then you've met all three of your client requirements. That's what a potential solution would look like. There's others out there. But just this is an example of how you have to pay attention to every requirement. Whenever you come up with an application design, you have to make sure you're addressing those requirements. We can't just overlook one. We can't pick and choose which requirements we fulfill. And I will tell you, be on the lookout for things like this on the exams. They do exist. They are meant to trip you up, but they're also meant to test how much you're paying attention, because this stuff applies in the real world every day. Moving on to RTO and RPO in disaster recovery designs. So this topic is near and dear to my heart. Disaster recovery is something that has been gaining popularity, especially in a cloud or hybrid-based environment. It doesn't matter who your vendor is, but first and foremost, make sure that you and your customer agree to the RTO and RPO targets and objectives. A lot of times I have seen assumptions are being made on one half or the other of the conversation, and then a disaster strikes and people are left scratching their heads and pointing fingers. It's never a good situation. Just as a clear definition here, a recovery time objective is the time it takes after a disruption to restore a business process to its service level. And you define that through an operational level agreement. These agreements and these objectives should be set by the business based on technology available today and the constraints that come along with it. So for example, if a disaster occurred at noon and the RTO is 8 hours, the DR process should restore the business back to service by a minimum of 8 p.m. Can it happen faster? Absolutely, that would be great. But during your solution planning, you need to make sure that whatever solution you choose gives you the flexibility where you can either recover or restore from a backup within that RTO window. A recovery point objective is the acceptable amount of data loss measured in time. So for example, a disaster occurs at noon, the RPO is 1 hour, the system should recover all data that was in the system before 11 a.m. The example I like to use here is, what if a system is compromised, it unleashes one of those nasty cryptoware viruses, and all of your files are encrypted on a system. That's a very bad situation. You need to make sure that, one, you stop it from spreading, but two, that you can recover from that by going back to a previous version of all of that data. Your data loss should only span 1 hour between 11 a.m. and 12 p.m. Those are good definitions. Those are the definitions I like. I think it makes it really clear the differences here if you've never been introduced to this. So now that we know about RTOs and RPOs, what does Amazon offer to assist us with disaster recovery? So in the prep phase of DR, it's very important to consider the use of services and features that support data migration and durable storage, because they really do enable you to restore the backed up data whenever disaster strikes. So some scenarios, you'll either keep like a scaled down or fully scaled deployment of your system somewhere else. When you react to a disaster, it's very essential to keep your compute capacity available. So if you lose an AZ, you need to make sure that you're in a position where your auto-scaling group can quickly spin up resources in the other AZ. If you lose an entire region, very rare, very, very rare, if it's ever happened. I do not have official statistics. But if you lose a region for whatever reason, you need to make sure that everything you need is available in another region to stand up. Keep costs in mind when you design your solution. Reserved instances help, but you have to remember that they're tied to a specific count, region, and availability zone. They're not easily transferable on the fly while you're fighting a disaster. AWS is available in multiple regions around the globe. So the advantage there is you can choose where your production site is, where your DR site is. You can comply with different governmental mandates. For example, if your data cannot leave the United States, you could deploy production into the East Coast region, US East 1, and you could keep your disaster recovery region in US West 2 over in Oregon. It gives you huge geographical diversity, but yet staying fully compliant with any governmental regulation.
You still there?
Yep, still here. Sorry
Oh,
about that.
no worries.
Knowing your feature constraints. So as you're designing a solution, you have to realize what your actual constraints are. Cost is one of them. It's not in the slide, but cost should always be in the forefront of your mind. Everybody's given a budget to use with DR. Make sure you meet those goals. But furthermore, look for availability versus durability SLAs. This could be SLAs within your organization. It could be SLAs offered by Amazon. Some services do not have SLAs. Make sure you find this information, keep it in your back pocket, and understand the difference between an availability versus a durability. A durability SLA means, hey, we're not going to lose your data, where availability means your data will always be online. There is a difference. Keep in mind what a particular storage type is good for. So we talked about S3 being a global service. S3 also has the ability to replicate its bucket to another region on the fly. It's eventual consistency, but we do know that it has that capability. It's object storage. What about EBS? You're tied to a single AZ. Make sure you understand what constraints come along with that. EFS. EFS is this awesome new service. It's NFS in the cloud. It is a regional service. You have local endpoints within an AZ. Typically you would deploy at least one per AZ, but it is a regional service. Then ultimately you have ephemeral storage. Ephemeral storage is that extra little bit of hard drive space that you get with some instance types, but it's really, you can think of it as a local hard drive attached to a machine. That data is only ever available to that one particular instance. It's very useful in some cases, but you do have to make sure you understand the constraints around all of these and when to use them. Learn what else is at your disposal. When you're looking at a DR plan, you need to make sure you understand what an AMI is, Amazon Machine Image, and what you can do with it. You can take an AMI image of any instance. Typically, you have to make sure that all data is stopped. Sometimes you have to shut it down if you're running a Windows instance, just to make sure your drive images are consistent. But once you have an AMI, you can copy it to another region. Very powerful tool when you want to make sure that you can spin up those web servers in another region at the drop of a hat. EBS snapshots. So like your traditional SAN type storage, you do have the ability to take snapshots on EBS volumes on the fly. Your first snapshot will always be a full write, but everything else will be deltas. You can replicate snapshots to other regions. And this can be fully managed. Lambda is a great way to write your own code to manage this stuff. There's a lot of examples online of how to do it. Highly recommend you seek that information out, but more importantly for this topic, make sure you know that that's available and how they work. We mentioned S3 bucket replication. You can shoot that data to another bucket in another region. Perfect. Another note with S3 replication is you can also replicate into another Amazon account if you have access. With IAM, you can grant cross-account access to different S3 buckets. Where this becomes effective is in a cloud-based environment. Not only do you have your standard security, where you have to protect your borders of your network, your logins to your servers, but you also have to make sure that you're protecting your Amazon credentials themselves. If I were to accidentally push a script out to GitHub that had my access key and my secret key, I've just given the world keys to the kingdom. You can come in directly through the front door. You could eliminate all my resources and empty all my S3 buckets. With S3 bucket replication, you can set up a one-way replication into a separate Amazon account to protect yourself against that kind of scenario. Make sure you have all of your automation code that can re-provision your instances for you in that separate DR account as well. There's a famous incident where this actually went south. There's a company out there called CodeSpaces. They did a site similar to GitHub actually. Problem is their credentials are compromised. Attackers held their website ransom after CodeSpaces had tried everything they could to clean their infrastructure. The attackers decided, okay, we're going to use these credentials to wipe everything, and they were ultimately bankrupt at the spot. It's a a scenario that's often overlooked, and I just want to call that out to your attention. When looking at DR, Route 53 health checks are very handy. Route 53 is a very geographically dispersed service. It's one of those global services that I talked about in data locality. So a Route 53 distribution has the ability to perform health checks against its ELB endpoints. So if US East 1A suddenly is not responding anymore, Route 53 will modify the DNS entries via alias records or however you have it configured, and it will start sending traffic to another region that's already set up with a worm standby. Very powerful in case you lose an instance, an ELB, et cetera, et cetera. EIPs, elastic IPs. EIPs are a good tool to use to mask failure within a multi-AZ deployment within a single region. EIPs get associated with instances. They're not necessarily provisioned with an instance all the time. So you can actually detach an EIP, elastic IP, from a running instance, and you can attach it to another one. Or you can have a watchdog script that has some logic that says, okay, instance A went offline, I'm going to detach the EIP and assign it to instance B. And there's a poor man's DR setup right off the bat. There's a lot of other tools out there, and that's where it falls under the etc. You've heard me mention AWS Lambda a lot. It's quickly becoming my favorite Amazon service. It's the ability to run functional code out in the cloud without having to manage an instance to back it. You get this whole serverless buzz, and I know some of you out there will say, well, there's still a server. That's true, but you don't have to manage it. It runs on demand as your function is called, and what's really handy is you can grant it permissions through IAM, and you can actually execute API calls, and that helps orchestrate a lot of this as well. So like the EIP thing, detaching, reattaching to another instance, same AZ, Lambda can definitely handle that for you. So if you're familiar with Python, Node, Java, I think those are the languages that have all been released, a couple versions of Node actually. You'll be able to whip together an easy script in no time and execute it through Lambda. So talking about some DR strategies in particular, backup and restore, the simplest, most effective DR strategy out there. So on premises, you typically back up either your virtuals, your physical servers to tape, you store your tape off-site somewhere, your data is ready when you need it. So here, Amazon S3, excuse me, there we go. Amazon S3 is object storage. It's an ideal destination to back up that data that might be needed quickly to perform a restore. So you can use bucket replication for availability. So let's say you've got a database server out there running on top of standard EC2. And you're sending, let's say it's a Microsoft SQL server, you're sending your .bak files out to S3 all the time. Well, if that instance ever went south, was terminated, stopped, blown off the planet, what you can do is you can fire up a new one and pull that .bak file down from S3, restore it, away you go. You can combine that strategy with lifecycle rules that you can apply to an S3 bucket. So you can move that data from S3 out to long-term archival storage via Amazon Glacier at an even cheaper cost. But watch out for your longer RTOs when using this method, because not only do you have to detect that something happened, but then you have to take action to manually restore an instance. You have to pull down that backup, you have to restore it. Or if you were using like EBS snapshots, same sort of situation. It's still not instantaneous to bring everything back online. Another strategy is a pilot light DR strategy. Pilot light is often used to describe a DR scenario where you have a minimal version of an environment running in the cloud. So let's say you have 30 web servers in US East 1 and you have one web server in US West 2. Yes, it's hot. But it's just like a pilot light in your furnace. It's a small flame that's always on, but it can quickly ignite the rest of it to heat up a house. So It's similar to a backup and restore scenario. You have to make sure that you're able to pull down the latest copy of your web server code, most likely off of S3 in this scenario, and then when you actually need to use it, then you begin your auto-scaling process after you've restored that data into that region. That's just another approach. I haven't honestly seen it used too often nowadays. I do tend to see warm standby used a little more often. Warm standby is when you have a scaled down version of a fully functional environment and it's always running in the cloud. So where a pilot light was just like a web server, or a web server combined with a .bak file for a backup of a database, a warm standby actually runs a hot web server, a hot database, hot middleware, whatever your app is. It's always running, but it's just scaled down to as small as it can be. And in the event of a disaster, you need to be able to scale that sucker up to handle the load. You also have to make sure that some critical infrastructure components are always available. So if you're running in a Windows shop, for example, you need to make sure that your Active Directory is also in your DR region. You don't want to be reaching across regional pipes to only find out that your original AD server, your master, is down and now you can't do user authentication or bring new machines online in the domain. You have to make sure that in a warm standby environment you have that core of your infrastructure running at all times, but then you can scale up from there. And lastly, multi-region active-active backup. This one is the least cost efficient, but sometimes you have an application that has been born in the cloud. I'm going to use the term cloud native. Let's say you have an application that is accessed globally. Let's think of a Netflix-like company. So you're hosting videos across the world. You want people to access the closest region to them. You're using CloudFront for CDN, but to take matters further, you start using Route 53's latency-based routing. You're pushing people to their closest regions. If a region disappears, you want to make sure that, okay, we've noticed, 1, 2, you take action on it. So the Route 53 automated health checks can kick in and say, okay, I just lost US East 1. I'm going to send my traffic to US West 2, or US West 1, or EU West 1, any of the other regions. The caveat with multi-region active-active is your data becomes your pain point, especially if you have an application that requires consistent data. So I used that example earlier where in the scenario where you have your 2 instances in 2 different AZs and your EBS data needs to be consistent. That sort of scenario will not work very well in a geo-dispersed regional situation where AZs have very low latent links between them. Regions are subject to public internet speeds. So when you develop a multi-region active-active application and DR plan, you need to make sure that you're okay with things like eventual consistency. You're using like a NoSQL database with replication, and that your application can handle these kind of situations. DynamoDB is a great example. You can use DynamoDB within a region. It's a regional service, but you can use Dynamo Streams and Lambda with triggers together to push that data to another region. I'm only calling this out because it is a valid strategy. It's only really used with wildfire applications that have to be available around the world. It is in use today, but it does require a larger budget to be able to pull something like this off. And I believe I've covered the 3 main topics that I was asked to talk on tonight. I do have some further recommended reading for you, though. Amazon has published a couple of white papers, and they're a couple of years old now, but the content is still very relevant. They give you architectural guidelines, even some CloudFormation scripts to get started with testing some of these scenarios and architectural designs. using AWS for disaster recovery. Great white paper. It talks about all of those DR strategies that I had mentioned, but it breaks them down a little bit further. Architecting for the cloud best practices. Another great white paper that Amazon published. Free, public, do what you will with it, but it does give you a really good, nice list of, don't do single AZ deployments unless you're sure you can get away with it. It's basically a very long checklist of things that if you're going to do, you must justify. And it's good to have handy. I have not added it to the slide deck, but YouTube is a great resource. And I say that because Amazon posts all of the reInvent sessions that they have at their yearly IT conference up to YouTube, usually within a couple weeks of the conference ending. All of those learning sessions are freely available. Take advantage of them. Man, YouTube was one of my greatest study resources when I was studying to go through all the exams. If you have a question, look up a YouTube session for reInvent on that particular topic, and I guarantee you that you will walk away with more information than you ever expected. It's that good.
Nice.
So yeah, I can't talk about that enough. But really, that's all I've got for the evening. I hope that you found this content relevant. I hope you found it interesting. I'd be happy to answer any questions that may be out there. If not, you can hit me up on Twitter anytime. I'm always looking to help.
So there's two reasons why we can usually get to the end of a series or of a session and have no questions at the end of it. One is because everybody's just passed out and fell asleep, but we still have a record number of attendees listening, so that's not the case. And the other reason is you covered everything in such great detail that nobody has any questions. And I think that the latter is the case this evening. I just checked the Twitters and the live questions, and dude, you nailed it. That was awesome.
Cool.
That was a fantastic presentation.
I appreciate that feedback. Glad I was able to help. But seriously, this is a great series on vBrownbag. All the speakers have done a phenomenal job, and I expect that to continue. I mean, this is great community. It's what it's all about. There you go.
Cool. Nice. All right. So if nobody has any further questions, then I will. Actually, one other thing that I wanted to mention: if you guys Google the AWS monthly webinar series, they have the archives of the monthly webinar series all on one page, and it goes from the getting started 100 sessions to the best practices 200 sessions to the deep dive 300 sessions as well. That is also another fantastic resource. I'm going to be going and checking out those reInvent YouTubes right now, though. That was some great advice. Thank you.
Yeah, not a problem. And you're spot on. Those webinar archives are great. Amazon always has upcoming live webinars that you're free to join. They do accept questions during those as well. And if you're more Twitter prone, a couple people to follow, you can check my following list. Jeff Barr, the media evangelist at AWS. If you're looking for a new service announcement, any kind of cool tool, he is usually one of the first to retweet it or post about it. All right. And then the hashtag AWS is also another good resource. It tends to get a little spammy at times, but occasionally you find some really good gems there. Nice. Well, I personally have a ton of questions about Lambda, but I'm not gonna muddle this excellent webinar with those questions. So I'm gonna go ahead and hit stop recording now. Tim, thank you very much, and we are